Welcome to the resource optimization training by Top Data Science. I start with the training content. So first, we are going to introduce who will be presenting in this session. And then introduction to our process optimization concept and approach. Continuing with an example customer use case where the solution based on this technology has been taken into use, providing value to the end customers for a specific industry. Then we describe the technical architecture in the context of RAMP and demonstrate how the end use application work with the process optimization technology through RESTful API. And then at the end, questions and answers. So that's the plan. So from Top Data Science side, I will be starting the presenting. I'm Kai Lehtinen, COO of the company, and making the introduction until technical architecture. Whom could you continue?
Yes, my name is Hunta. I'm CTO at Top Data Science, and in this project from Top Data Science side, I'm technical lead. And today I will give the technical architecture in the context of RAMP. Luke, please.
Yes, so I'm Lukta. I am senior software engineer at Top Data Science. I will continue with the demonstration of how end use application will work through RESTful API.
Okay, thank you guys. So I will start. This is the RAMP and Beta Factory conceptual breakdown. And I'm sure you are very familiar with it. And just to give the context and focus for this presentation, we are providing technology and the services to this resource optimization part of Beta Factory and its apps capabilities. The focus area for us in Beta Factory is to further develop the AI-based optimization capabilities, especially in the area of process optimization. Our primary focus, from where we have started this technology development and co-creation, has been pulp industry, where we are serving with this same core technology industrial customer with the multiple sites in multiple countries, and the development around that is continuous. So adding new capabilities to it as we speak. The optimization approach and technology can be used for other industries as well, and that's why we are providing this to this Beta Factory environment. The AI technology approach, what we have here is to use deep learning in modeling and predicting the process performance. Then going through the optimization architecture or concept approach that we are starting with. So it's described here on the right, and it includes different type of parameters and tags, constraints that are used to steer how this optimization is done. Some of them are like controllable. Some are based on certain stages. There can be one or multiple stages within the process. And of course, there are constraints that are like affecting to a process and how it should be optimized. Out of this optimization comes out kind of information about maximized performance, whatever is the objective that we are optimizing against, and how that performance can be achieved through optimized controllable tags. Although this approach is generic, each industrial use case have certain specific features that needs to be taken into account while setting up this this solution environment, and that relates to kind of a selecting stages, right parameters, and with that also what type of deep learning algorithms or models should be used in this specific context. The basic requirement for applying this type of optimization is to have some historical data about process performance. So it's a combination of utilizing historical data and then like close to real-time data to predict the future performance. And this RESTful API, the type of integration layer that RAMP has, is a way to kind of provide data in and also data out from the process as needed. A little bit continuing the same, but still generalizing a bit. So so that same thing describe how from that perspective how this could be applied to different processes and industry segments, is that you need to start by defining the process and its stages. You need to identify an optimization objective or objectives. You need to identify the input parameters, whether they are like stage tags or then controllable stacks that you can like affect to. Of course, you need to have then integration thought through and data pipelines relating to that. That is kind of a part of this RAMP architecture and platform. Then having access and providing the historical data for the model training and optimization reasons or to enable that is key thing here. And that is something that kind of need to be evaluated per a case, that how much historical data, how long time, what kind of data is needed in order to make credible and accurate predictions based on this modeling approach. There is certain basics really thought profoundly when it comes to optimization through deep learning that is used here, and then of course you need to test the model how it really predicts the performance and is the process performing according to the predictions. So this is kind of a continuous process that will improve as it is taken into use. And at the end, when everything is tuned to be close to optimally defined and configured to deploy this solution to production. Then continuing directly to an example use case that is testifying the value of this type of technology and approach. And we have implemented an industry-specific end-user application or product based on this same technology called Aiya, which is an AI-based solution for high-performance industrial processes. On the right-hand side, you can see an user interface, the end-user application that was designed for this specific industrial purpose. It is very intuitive, quite easy to use. That is showing the past performance of a process and where we are at the moment, and what is the predicted performance of the process going forward. There are different predictions, some that are like showing that if we go with these parameters, controllable controllable parameters, what will be the performance of the process in that case? And then if we are modifying the parameters, what will be the impact on the process performance based on these modifications? So it is really intuitive way to understand that how the process is impacted per stages, and how do the organization operate the process in order to meet set quality targets with optimized costs and for example usage of chemicals as one example. There has been significant benefit for the business itself, but also it's helping the organization and personnel to understand that how the process is performing and how can I steer it in different production scenarios. So just summarizing the key benefits, improved ability to predict and control. So foreseeing what will be the production performance with these settings based on the history information and the current state of the process, and when it is reconfigured, what will be the impact of that. Thus, it has also this control element to it. These times, having this sustainability element in more or less any industrial process is more and more important, and this is genuinely enabling minimize the use of raw materials, energy, and for example, in this case of pulp and paper, the use of chemicals to achieve the set product quality requirements with optimized use of different type of resources. An improved working environment which came through this transparency of the process and ability to steer it and understand the impact of made changes to the process. Maybe adding this capability that comes with this type of modeling approach, that we have enabled in this Aiya context also simulations to predict different performance outcomes based on different configuration settings. So kind of doing near time within days or hours, that what are the choices for the operative personnel to enable achieving the product quality objectives, whether there are some scenarios that will enable achieving needed quality with the lower cost. So these type of simulations have been of a big interest for our customers in this specific industry segment. And these different configurations in this setup we have enabled also storing those for future usage. Then ending that in this case, this functionality that is developed by us on top of this technology that we are providing to the ramp has been added this end user application, and this is a genuine image from operative dispatch control room where the operative personnel are kind of checking where the process is and what should be the configuration changes in order to impact the process according to the objective. So it's very intuitive and thus helping the operative personnel and the engineers to do their work in a professional manner. So that was my introduction to the topic, and then I will give it to Hung, and could you continue with the technical architecture introduction to the, let's say, next level of depth and in the context of RAM.
Thank you, Kai. Could you show the next slide? Yes, thank you very much. So this slide describes the architecture diagram of the process optimization service provided by Top Data Science. We call it ProOpt. ProOpt has three main functional modules that implement three main functions and communicate with the end-use application through a RESTful API. The first module is model training. This module receives a training dataset and model specification from external applications to run a training pipeline and results in predictive models. The models can be stored in the RAM storage for later use by other modules. When the trained model are available, external application can use the second modules, which call prediction and simulation modules. External application send the process data to ProOpt, which will be transferred to the prediction and simulation modules. And there, the module will make the predictions and return the prediction to the applications. External application can also alternative the process data and send the data to the simulation module, which allowed to simulate different scenarios of the process. And the third module is control optimization. This module is responsible for finding the optimal process setups to achieve the target, the quality target. This module will receive the process data, the optimization constraints, and the target quality from external application. And then it runs the optimization algorithm. The model will return the optimal values for each process parameters together with the achieved quality. And next, Dutta will demonstrate how the external application will communicate through the RESTful API to use three functional modules as has been described.
So I will be I stop sharing now, and Duke, could you please take over?
Yes, okay. Yeah. Thank you, Kai. And let me share the screen. Okay. Can you see my screen?
Yes.
Yes, we can.
Yes. Yes. So here is the API, the process optimization API. It follows a RESTful API, and the API also protected using the RAM authorization and authentication layer, which the token after the end application login, there could be a token, and they can forward the token so that they can access any end application, can access a model or any access store in the RAM storage. And inside the API, there are four important endpoints. The first two endpoints is for prediction and optimization. The last two endpoints is for training. In training endpoint, the first endpoint here is for queuing a new training. So like Hung has mentioned, the training will receive the model name, the data here, like representing the historical data. So I also want to mention that here is the test data. The next parameter here is input tag and also the target tag. Then this payload will be sent to the training endpoint, and it will be forwarding to the model training module in the architecture slide. And when we execute the training, we will receive a response as the training is running and the model could be available or still in progress of the training. So after the training is done, user can also fetch the model status anytime. So for example, if the model training take a few minutes or longer, then they can fetch the status of the models to know if it's available or not. If it's available, then user can move forward with the model endpoints. In model endpoints, the first endpoint here is the predictions. In prediction endpoint, we specify the model name and also the latest data of the task. Here, in format, we specify timestamp and the tag name and tag value. And when we submit the payload, the server will forward this data to the prediction and simulation module, and this module will load the model, the train model, and use it to generate the prediction. The prediction is returned with values of coming time window in the future and with predicted values. By changing any value here, so user can simulate the parameter if needed. So instead, for example, if the tag name 2 here instead of 20, any application the operator want to control it into 10, and they can specify an alternate values to make a simulation, and it will return the prediction, but it's at the simulation of the control tag. Next here is the optimization module. The optimization module accepts the task parameter. So by telling the task they want to get the optimized values, this payload will be sent to optimization module, and running the optimization algorithm, it will return back the proposed optimized value from the system. So user will receive the proposed optimized values from the system like this. And all of the training models are saved in RAM storage for later use. That's why the alternate authorization is needed and in the use of the process optimization API. I think that concludes my quick demo. I hope this is easy to see, like how it easy to use the process optimization module. And also I forgot to mention the process optimization module is running in Docker image, so it's quite easy to set up as well.
Thank you, Duke. Hung, would you like to add something to this demonstration from technical architecture and how to use these services point of view?
Yes, maybe it's worth to mention that the model training is not always required like every time. So, which means that we only need to do it until we have the working model. And with this API and this, we also can support active learning, meaning that the external application also can collect the feedback from users and then improve the data set and improve the model in any regular base, depend on the requirement from the external applications.
All right, so that was our training presentation. We thought to have this very practical approach to this. So explaining what is our overall solution approach here, how it relates to ramp environment with this use case that the value has been proven, and then through this a very simple demonstration that is showing the APIs and related capabilities. So with that, I think we are opening it up for questions, and we are happy to answer.